So back again, once again. I have done just the first part of work power energy. Today I would like to finish up the first part. Okay. Make sure you are revising at home. So last time my discussion was regarding work. Today I would like to discuss about power. Let's discuss about power. What is power? So whenever we are discussing about power, we say the rate of doing work is power. Power is rate of doing work. So whenever everything is written with rate, that means it is written to time. So you can say power equals to work by time. So it is related to time. Please understand. Vice versa. So we can say power is dependent on two factors. One is work, amount of work done. Other is amount of time that is required. Two factors on which power depends. Vice versa, we know work equals to force into displacement. So what we can write this one as? Power equals to force into displacement by the time. That means what? Force into displacement by time. That means force into velocity. So we can also express power in the terms of power equals to force into velocity. Okay? So please understand this one in a logical way. Suppose, see, the relationship between power and time is inversely proportional. Whenever the time is less, the power is more. Whenever the time is more, the power consumed is less. Like suppose two persons are doing a work. Two persons are lifting a load from the ground floor to the first floor. Suppose there are two persons A and second person B. Person A requires 5 minutes. Person B requires 15 minutes. That means person A is requiring less time, person B is requiring more time. Please understand the relationship between power and time. It is inversely proportional. More is the time, less is the power. Less is the time, more is the power. So obviously we can say the efficiency of person A is much more. Why? Because he is taking less time to do it. We will understand the units of power also. Let's go to the units of power. What are the units of power? See, understanding the units, you don't learn the units of this. You can derive the unit yourself. Like we can say, what is the SI unit of work? SI unit of work is what? Joule. And the SI unit of time is what? Second. So we can say power is joule by second. So when we are saying 1 joule work is done in a time of 1 second, the power consumed is said to be 1 watt. Please understand this. Suppose a person or a machine or anything does 1 joule of work in 1 second, the power consumed is said to be 1 watt. This is the SI unit of work. This is very important. There are multiple units. The multiple units is kilowatt, megawatt, gigawatt. These conversion units you should be knowing. Like 1 kilowatt equals to, kilo means what? 10 to the power 3 watt. 1 kilowatt equals to 10 to the power 3 watt. 1 megawatt will be how much? 10 to the power 6 watt. In this way, 1 gigawatt equals to 10 to the power 9. 1 gigawatt equals to 10 to the power 9 watt. This relationship between watt, the SI unit and the multiple units, it should be knowing. The smaller units are also available, like milliwatt, microwatt, all these things are available. Now, one of the most commonly used units is horsepower. You should be knowing between the horsepower. What is horsepower? Horsepower or HP. 1 HP equals to 746 watt. Please remember this. Very important. This is one of the most commonly used, especially in mechanical engineering. This is the one that is commonly used. 1 horsepower equals to 746 watt. Okay. So I hope you understood the relationship between power and work. See, work is equals to force into displacement. Power equals to force into displacement by the time. So there, in work, it is not related to time. In power, it is related to time. So in your book, you will find the difference between power and work. You should be doing the same. Okay? Now let's understand something about energy. I hope power is clear. Let's understand something about energy. Now, energy. Energy, what we say? Energy is the capacity to do work. That means, see, understand in this way. I don't have food for 5 days. Do I have energy? No. How will I judge my energy? I will judge my energy by the amount of work I can do. Right? So it's similar to that of work. It is similar to that of work, but exactly not just with work. The measurement is done by the amount of work that is done. If I can do some work, that means I've got energy. Got it? So if a body does work, its energy decreases. If work is done on the body, the energy increases. Okay? So the units of energy, let's come up to the units of energy. What are the units of energy? Units of energy. When we are talking about units of energy, we need to understand the SI unit of energy is joule. SI unit is joule. And CGS unit will be? CGS unit will be earth. Please understand, the unit is same as that of unit of work. The unit of energy and unit of work is the same because we are measuring the amount of energy with the amount of work that is done. Now, there are some bigger units which is most commonly used, especially for electrical energy. We use energy measurement as kilowatt, kilowatt hour, or watt hour. We use watt hour or kilowatt hour. These are the measurements that are used for electrical energy. Very important to understand about kilowatt hour and watt hour. Let us understand about kilowatt hour and watt hour. What is kilowatt hour? What is watt hour? Watt hour. What do we say 1 watt hour? 1 watt hour equals to 1 watt into 1 hour. Please understand. 1 watt hour, this is usually used for measurement of electrical energy. Okay? 1 watt hour equals to 1 watt into 1 hour. What is 1 watt? We just understood now. 1 watt equals to 1 joule by per second. And 1 hour, if I write in SI unit, it is 3600 second. So this 3600 second, ultimately what do we get? We get this one as 3600 joule. Seconds cancels. So we get this one as 3600 joule. That means 3.6 kilojoule. So 1 watt hour means 3.6 kilojoule or 3600 joule. So what is 1 watt hour? 1 watt hour is the amount of electrical energy consumed. 1 watt hour is the amount of electrical energy consumed or work done by an electrical appliance when it does one work in 1 hour. 1 watt hour is the amount of electrical energy consumed by a source or an electrical appliance of 1 watt in 1 hour. Similarly, the bigger unit is kilowatt hour. What will we write as kilowatt hour? Kilowatt hour, that is 1 kilowatt into 1 hour. 1 kilowatt means what? How much watt? 1 kilowatt means 1000 watt into 1 hour, that means 1000 joule per second into 3600 second. So what do we get this one as? 3.6 into 10 to the power 6, 10 to the power 6 joule, 3.6 into 10 to the power 6 joule, that means 3.6 megajoule. Please remember this direction. This direction is also important for you all because these do very frequently come. What can we say is defined as 1 kilowatt hour? 1 kilowatt hour is the electrical energy spent or consumed by an electrical appliance of power 1 watt in 1 hour. So this is the power. This is the time. So power 1 watt, 1 kilowatt in 1 hour. So 1 kilowatt hour is the electrical energy consumed by an electrical appliance of 1 kilowatt in power 1 kilowatt in 1 hour. So this makes us 3.6 megajoule. Okay. Now another units, whenever you buy any foods, you find or people doing some work, they say I burn out how many calories. We usually measure energy in the form of calories also. So this is one of the commonly used units, calorie. You should be knowing the conversion of calorie. 1 calorie, let me write this one. 1 calorie equals to how much? 4.2 joule. 4.2 joule. To be precise, it is 4.18 joule. Okay. You can also write this one as 4.2 joule. This also comes in exam. 1 calorie equals to 4.2 joule. Now there is another unit that is used, is known as electron volt. Very, very important. This has come several times in ICSE. The relationship between electron volt and that of SI unit. Okay, please remember the relationship. 1 electron volt equals to 1.6 into 10 to the power minus 19, 1.6 into 10 to the power minus 19 joule. Please remember this. This relationship do come in exam. So 1 electron volt equals to 1.6 into 10 to the power minus 19 joule. So what is 1 electron volt? How we define this one as 1 electron volt is the energy spent by an electron when it is accelerated. We don't know all these things. 1 electron volt is the energy spent. How much amount of energy is spent when it is accelerated by a potential difference of 1 volt. Suppose I have got 2 points A and B. I have given the potential difference of 1 volt. Potential difference of 1 volt I have given over here between these 2 points. So, and you know, whenever electricity flows, it is nothing else but because of the flow of the electrons. So, whenever the electron is flowing, it is accelerating because of this potential difference. So, what we will say? 1 electron volt is the energy gained by an electron. How much amount of energy this will gain? Suppose this is moving from here to here. This electron is moving from this point A to point B. So it has to gain some amount of energy to move. So amount of energy gained by electron when it is accelerated in a potential difference of 1 volt. So if I convert this one to joule, it becomes 1 electron volt equals to 1.6 into 10 to the power minus 90 joule. So this is what was there in your work power energy first part. The very next portion will be the different types of energy we will be discussing. That is kinetic energy, potential energy. Okay? So coming back to the next video. Please do revise at home. Make sure do not waste your time between this COVID-19 lockdown situation. Thank you.